Hi, it's Mrs. Pope, and today we're going to be talking about absolute value equations. We have two goals that we would like to achieve by the end of this video, and that would be to evaluate absolute value expressions and solve absolute value equations. So the difference between expressions and equations, expressions aren't going to have equal signs. It's just something we're going to plug in numbers and evaluate. Equations actually have equal signs, so if you do something to one side, you have to do the same thing to the other to keep them equal and balanced. So our vocab for this lesson, absolute value of a number is its distance from zero on a number line. And it's always positive, and let's talk about that. This is the symbol you'll see for absolute value to have the two little brackets around whatever you're taking the absolute value of. I just put X, there could be a number in there, a polynomial, binomial, anything. And here's our number line. So let's talk a little bit about what absolute value actually means. In the definition, it says it's the distance from zero. So it's always going to be positive. If I have the absolute value of 4, the question, or what it's saying is, how far is 4 from 0? Well, of course, if we're at 0, to get to 4 on a number line, we'd have to move 4. So the absolute value of positive 4 is 4. But also, the absolute value of negative 4, if the question is, how far is negative 4 from 0? Well, if we're at 0, it doesn't matter that we're going negative to the left. The question is, how far is it from 0? So it's still only 4 units from 0. So the absolute value of negative 4 is going to be positive 4. So no matter what happens when you're coming, anything that comes out of the absolute value signs will always be positive because it's really just asking how far is it from 0. Doesn't matter if it goes inside positive, goes inside negative. When it comes out, it's just going to be a positive number. All right, let's look at some actual examples. So example 1, we want to evaluate. This is an expression. So 8.4 minus the absolute value 2n plus 5 if n is negative 7.5. So they've told me what the value of n is. I want to plug that in to see what I could do if I were to evaluate this expression. So 8.4 minus 2 times, and notice the negative 7.5. I've replaced this in here. So this was n. I've replaced it with negative 7.5. That's what happened here. So notice it said step 1, replace n with negative 7.5. And so we've done that. Then if you simplify, I haven't changed anything out here, 2 times negative 7.5 is negative 15. And then we carry down to plus 5. And here I want you to be careful. You want to make sure you wait until the last second. Wait until you've simplified all the way down before you take the absolute value. So simplify before taking the absolute value of the number. So I don't want you to take this negative 15 and say, oh, it's inside of the absolute value. Let me make it positive. No, you need to simplify all the way down first. So negative 15 plus 5 is negative 10. Now we can simplify it and take that down to a positive 10. So 8.4 minus 10, and that would, of course, equal negative 1.6. You can check your work and see if that works for you, and double check that your answer is correct. Let's look at the next example. So evaluate 4x plus 3, the absolute value of 4x plus 3 minus 3.5, if x is negative 2. So we know that x is negative 2. The first thing we're going to do is replace x with negative 2. So I have absolute value of 4 times, not x, but negative 2 plus 3 minus 3.5. If we simplify that, we have the absolute value of negative 8 plus 3 minus 3.5. And remember, simplify first before you take the absolute value. So negative 8 plus 3 is going to be the absolute value of negative 5 minus 3.5. Remember, don't take that early. And then the absolute value of negative 5, of course, is just 5 minus 3.5. So 5 minus 3.5 is equal to 1.5. And that would be your final answer, 1.5. All right, let's look at a couple more examples. Remember, you can always check your work and make sure you're correct. All right, example 3 says, solve 9 is equal to the absolute value of x plus 12. These are a little bit different. So here, remember, whatever comes out of this, whatever is inside of there is going to come out positive. So I could make this magically turn into -9, and then if I took the absolute value, it would be 9. Or it could turn out to be +9 inside here. If I took the absolute value, the answer would be 9. So when we're solving these types of equations, we have two scenarios to look at. We need to look at if this came out to be -9 and if this came out to be +9. So we're going to create two separate equations to solve. The first one you create is almost exactly as you see it. Now I did write the x on the x side first. I just flipped them. You can do that, or you can keep it this way. 9 equals x plus 12. It doesn't matter. So here we have x plus 12 is equal to 9. So all I did was took away the absolute value signs. And then the other one we're going to look at is x plus 12 is equal to -9. Those are our two different options. We need to look at both of those because both of them indeed should work. So here we're going to do regular solving. So let's just solve. We want to subtract 12 from both sides. So x plus 12 minus 12 is equal to 9 minus 12. These cancel out. X is equal to -3. That's one of our answers. And now let's check the other one. We still need to subtract 12. X plus 12 minus 12 is equal to -9. These cancel out. I didn't write my minus 12. So x is equal to -21. And either of these are going to be correct, -3 and -21. So let's see if that's true. Let's check. If I plug in -3 to my original equation, let's check. Do I get 9? -3 plus 12. Yes, -3 plus 12, that would say 9 is, question, is it equal to absolute value of -9? Yes, it is. 9 equals 9, so that's correct. And it's very important to check these every single time. So let's look at -21. Is 9 equal to -21 plus 12? Well, what's -21 plus 12? It's going to be -9. 9 equal to absolute value of -9? Yes, 9 equals 9. So that is, well, that shouldn't have been negative. Ooh, maybe you caught that. This should have been -3 plus 12 is +9, but still the absolute value would have been positive. And then here, absolute value of -9, 9 is equal to 9. So your final answer are both of these together. -3 and -21. Kind of write them like an ordered pair, but with the brackets shows me it's not an ordered pair. It's saying these are the two solutions to this. All right, let's look at the next example. Example 4, solve. We have absolute value of x plus 10 is equal to 4x minus 8. So we have two possibilities. Whatever comes out in here could have turned out to positive 4x minus 8, or it could have turned out to negative 4x minus 8. Those are our two options that we have to use. So we created two equations. The first one is exactly as you see it without the absolute value signs. And we're going to solve that one. The second one, I have x plus 10, is negative 4x minus 8. Because it could be positive or negative. Whenever you take out the absolute value, remember it's going to come out to the positive answer. So let's go ahead and solve these two and then check our work and see what we get. So here we want to combine our like terms. So I would go ahead and move the 4x to the left side. So we're going to subtract 4x on both sides. So x minus 4x plus 10 is equal to 4x minus 8. X minus 4x plus 10, we have x plus, x minus 4x, we have negative 3x plus 10 is equal to negative 8. And we're trying to solve for x, so let's subtract 10 from both sides. These go away. Negative 3x is equal to negative 18 divided by negative 3 divided by negative 3. X is equal to 6. So this is one of our answers that we have here. X is going to equal to 6. We're going to try the second one, see if we get something different, and then we're going to go ahead and check them both. So before I start, I want to distribute this negative here. So my x plus 10 hasn't changed. Let's make this clear. This is the second one. X plus 10 is equal to negative 4x plus 8. So make sure you distribute that negative correctly. Negative 4x plus 8. So now let's get all our x's on one side. I would add 4x to both sides. So x plus 4x plus 10 equals negative 4x plus 4x plus 8. And then we have 5x plus 10 is equal to 8. We're going to subtract 10 from both sides. Plus 10 minus 10 is equal to 8 minus 10. These cancel out. So 5x is equal to negative 2. Divide by 5. Divide by 5. So x is equal to negative 2/5. So now we have two different answers, and we want to check those. We want to check and see if they would be equal. So let's look at 6. If I put in absolute value of 6 plus 10 is equal to 4 times 6 minus 8. 6 plus 10, absolute value of 16 is equal to 24 minus 8. This is 16. This is 16. This works. All right, so now we know that this one works. We want to check and see if the negative 2/5 works. So if I took absolute value of negative 2/5 plus 10 is equal to 4 times negative 2/5 minus 8. So we need to check both of these and see if they work. Well, negative 2/5 plus 10, you can turn it into a decimal or you can add the fractions, however you want. I tend to turn them into decimals. So here I would get, if you turn it into a decimal, negative 9.6. So we have the absolute value of negative 9.6. And then 4 times negative 2/3. As far as if you do fractions, of course, you're going to have negative 8/3. You can turn that into a decimal and then subtract 8. You end up with negative 9.6. So you end up with negative 9.6, but over here I need to take the absolute value. So the absolute value of negative 9.6 is 9.6. So that does not equal negative 9.6. So this one actually is not a solution. It's an extraneous solution. It's one that worked algebraically, but when you plug it in to actually try it out, it doesn't end up working. So our final answer only includes the one that works. So the one that worked was x is equal to 6. So in our solution set, we should simply have a 6. We should not include the negative 2/5 because it did not work when you checked it out. All right, thank you for watching, and remember, you are responsible for your own learning.